Hello everyone. I am Huizu Jiang, an assistant professor at Northeastern University. Today I am excited to present Bongard HOI, benchmarking few-shot visual reasoning for human-object interactions. This is a joint work with my awesome collaborators from UCLA, NVIDIA Utah Austin, and Caltech. Xiaojun Ma and I made equal contributions. In most of machine learning benchmarks, a visual concept, like bicycle, is defined as a set of images covering different colors, models, etc. Similarly, we also need images of person riding various bicycles for a new concept. This way of concept learning, however, requires a large amount of training data. And there is no clear way for a model to generalize beyond the concepts seen in the training set. In this work, we present a new benchmark, Bongard HOI. In each task, a set of positive images containing a concept are given without the concept name. At the same time, negative images that do not depict this concept are provided too. Query images are to be classified depending on whether they contain the common concept depicted in the positive images or not. For instance, the top query image has a positive label. In Bongard HOI, we consider the human-object interactions as the underlying visual concepts. To make it challenging, we select hard negatives for each concept, where all images contain objects of the same categories and only human-object interactions are different. In this way, simple visual recognition is not sufficient. Instead, visual reasoning of the human-object interactions is needed, for example, context-dependent reasoning. Our work is inspired by the original famous Bongard problems and recent work of Bongard logo. In our new benchmark, our concepts involve the compositions of objects and actions. So, we can generate different splits in the test set by controlling whether they are seen in the training set or not. From fully seen to partially unseen and fully unseen, the difficulty gradually increases. In this way, we can systematically study the performance about a model's generalization ability. Like I mentioned earlier, our benchmark requires context-dependent reasoning. What does it mean? Here, given a set of positive and negative images of drink with cup or not, the given query image's label is negative, but the same query image receives a positive label among different contexts, where the positive images are about hold cup. This characteristic makes Bongard HOI different from other few-shot learning datasets, where an image always has a fixed label. Compared with other benchmarks, HOI detection ones focus mainly on recognition and do not require the reasoning skills. Few-shot learning datasets, such as Mini-ImageNet, focus on few-shot learning but ignore other reasoning skills. While most of other visual reasoning benchmarks, like Bongard logo, are about synthetic shapes, our benchmark is built on top of natural images, imposing unique challenges. We model the concept learning as a two-way six-shot learning problem and resort to meta-learning models. We consider state-of-the-art model, meta-baseline. The feature of a query image is compared to the mean features of the positive and negative images to get its label and compute the loss. Given an image, we first get a set of category-agnostic objectness detections. Their features are paired and aggregated as the representation of the image. We tried different pre-training for the RESNET50 backbone model, including from scratch, ImageNet pre-training, and self-supervised training of MoCo V2. Here I am showing the accuracy of model on different test splits. With an encoder that has no pre-training, the accuracies are barely better than the random guess. For a model with a MoCo V2 pre-trained RESNET50 model, it performs sometimes better than the previous model but sometimes worse. With ImageNet pre-training, it consistently performs better than no pre-training and self-supervised pre-training of MoCo V2. All the results so far are about using bounding boxes from an objectness detector. What if we use ground truth bounding boxes? We can see its accuracies get improved, but not too much. We also hire human annotators to work on our benchmark. As we can see here, there exists huge performance gap between machine learning models and humans, where human-level accuracies are around 90%. To summarize, we introduced the Bongard HOI benchmark, highlighting the visual reasoning skills. We test state-of-the-art meta-learning models, but they do not work well enough. Compared with humans' performance, machine learning models' accuracies are far below. Our data and code are publicly available. Welcome to our poster at 36B for more details. Thank you.